Hello, folks. Thanks for joining me today. I'm Mike Reed. I work in Intel's Security, Software, and Services Group. We build technologies like Intel SGX and Intel TDX. And I'm going to talk to you today about tools, specifically tools for confidential computing. After all, OC3 is a gathering of builders. We work together on technology and tools to help solve customer problems. So let's take a look at some of these tools. Now, when I think of tools, I'm reminded of a trip to the hardware store. I love going to the hardware store. It's one of my favorite things to do on a weekend. I enjoy walking the aisles and imagining what I might be able to build with the tools at my disposal. Tools are delightful in and of themselves, but the real joy comes from using them to solve problems. Today, I'm going to give you a look at some of the tools Intel can put into your confidential computing toolkit. So let's get started. Let's go to the hardware store. Let's go shopping. I mentioned I really enjoy wandering the aisles at my hardware store. I could spend an entire afternoon there looking for ideas or new equipment. But today, we're on a limited schedule, so we need a bit more of a plan. Let's take a look at some of the departments we'll visit today. We'll start in the silicon department, where we'll look at the Intel Xeon roadmap and see what it has to bring to our confidential computing toolkit. Then we'll move to the software department, specifically software for Intel TDX. And we'll look how that software makes TDX available to more customers to solve more problems. Then we'll go to the all-important artificial intelligence department, where we'll look at how CPUs can work with GPUs to deliver accelerated confidential AI solutions. Then we'll turn the corner into the Attestation department. We'll get a demonstration of Intel Tiber Trust Authority and see how it works in the cloud, on-prem, or at the edge. And finally, we'll look at ways we can work together on open source software in industry initiatives and make this industry stronger, advance confidential computing together. Let's start with silicon. Folks, trusted execution environments are rooted in hardware. They're the essential tools for confidential computing. It's been said that if all you have is a hammer, every problem looks like a nail. But since Intel trusted execution environments offer both application isolation and VM isolation, you could pick the right tool for your job. Intel SGX is designed for our most security-minded customers. They like its small trust boundary and its granular workload attestation. Customers using Intel SGX today include Microsoft, who uses SGX to help secure tens of billions of annual online transactions. IBM is using SGX with the German Health Ministry and using it to protect the electronic medical records and the prescription transactions of the entire country. Signal uses SGX to help protect the privacy of its messaging network. So VM isolation with Intel TDX is growing rapidly thanks to its ease of use and low overhead. Today, Alibaba, ByteDance, and Baidu are offering TDX services in China. Google Cloud is offering a TDX service in the United States. And previews are coming soon from Microsoft and IBM. So stay tuned to this space. Let's look at the Intel Xeon roadmap. It helps bolster your confidential computing toolkit, providing more and more capabilities over time. Let's look at how Intel trusted execution environments and confidential computing features evolve across the Xeon roadmap. Application isolation with Intel SGX continues across the entire roadmap, remaining as a unique capability of Intel confidential computing. You may recall a few years ago, VM isolation with Intel TDX started as a limited offering. I'm happy to say that today, TDX is available generally and offered with a breadth of Intel Xeon processors. With Intel Xeon 6, we started our conversion to post-quantum cryptography, increasing our memory encryption strength with AES 256-bit encryption. Expect additional PQC updates to be coming to the Xeon roadmap So keep an eye on this space. On February 26, we launched our latest members of the Xeon 6 product family. We also announced that the Xeon 6 with P-cores includes hardware support for Intel TDX Connect. This is an essential technology for confidentially connecting CPUs with GPUs. Support for Intel TDX carries forward to our next generation mainstream Xeon processor. Intel packs several features into its Xeon product line to help us build our confidential computing solutions. I want to share one specific feature with you today. Our next generation platform will introduce a new memory protection feature called cryptographic ECC. It helps defend data integrity in both confidential and non-confidential use cases. Let me explain a little bit more about cryptographic ECC. Today, error code correction memory, or ECC memory, can detect memory bit changes and stop workloads from consuming corrupted lines of memory. But unlike encryption or hashing algorithms, ECC coding is predictable. It's deterministic, and it's well known throughout the industry. Rowhammer is a class of attacks where the attacker repeatedly accesses a row of memory cells. These repeated accesses cause electrical interference and could cause values to change in adjacent cells. A skilled adversary capable of staging a Rowhammer attack could turn ECC determinism to their advantage. In this scenario, the attacker uses Rowhammer to change specific memory bits. This creates an error pattern that causes ECC to miscorrect the memory line to a corrupt value. The most insidious part of this Rowhammer attack is that the data corruption looks like an error correction, so it probably wouldn't be detected by most software applications. An example of this is you could be changing a value from true to false, or the software could be expecting $1,000 instead get $1 million. This vulnerability, originally named exploit, was first documented by researchers at Vrije University in Amsterdam. This attack is possible because of determinism of ECC algorithms and their error patterns. Cryptographic ECC removes that determinism and makes this attack impractical. On a memory write, data and ECC values pass through a blinding algorithm. That blinded data is then written to DRAM in a non-deterministic fashion. The attacker can't determine which memory cells to hit with a Rowhammer attack and engineer an error pattern that will be miscorrected by ECC upon read. Rowhammer attacks are still possible with cryptographic ECC in place. However, cryptographic ECC exponentially reduces the probability of pulling off an undetected attack. If bits are flipped in memory, they'll appear like a random memory error. They'll be recorded, corrected if possible, or handled using standard error flows if they're uncorrectable. Unlike a prior technology we offered in this space, cryptographic ECC does not consume ECC bits, so it's expected to have negligible performance impact. All right, let's leave the silicon department and pull ourselves over into the software department and look specifically at software for Intel TDX. Guest OS enabling for TDX has been completed for some time now. You can choose from leading Linux distributions, or you can even choose a Windows Server guest OS if you're hosted on Azure. Host OS and hypervisor enabling is progressing rapidly. Over 3/4 of the base TDX patches are merged into mainline Linux today. We anticipate a full merge later this year. If you want to get started now, ahead of that full merge, early preview distributions are available from Canonical, from SUSE, and from Red Hat. We're also excited to see TDX support coming to the on-prem space with VMware. And VMware's vSphere 9.0 to be soon announced will be the first time that VMware supports TDX. 2025 is a big year for the software space around TDX. So stay tuned here. Come back to this department often. See what's new. Up next, let's talk about GPU-accelerated confidential AI. More and more companies today are finding more and more uses for AI and putting their business data into large language models to make that work for their business. So this is a great time to look at adding a connectivity between CPUs and GPUs or confidential AI to your toolkit. There are a couple of ways to connect CPUs and GPUs confidentially. The first one's called a bounce buffer. Here, encrypted data and messages are passed across an open PCIe connection. NVIDIA offers a bounce buffer today that supports Intel TDX. NVIDIA provides that bounce buffer through a deployment guide that allows you to deploy and run your own servers with Intel CPUs and NVIDIA GPUs. But if you want something turnkey in the cloud, Google Cloud is also offering a preview today of the NVIDIA bounce buffer on their A3 machines, featuring an Intel CPU and TDX, along with an H100 from NVIDIA. Go check it out. It's in preview today at Google. And TDX Connect is the ultimate evolution of confidential connectivity. It brings end-to-end encryption across PCIe and eventually CXL. This provides seamless, direct sharing between a CPU and a device trusted execution environment like a GPU. This also provides higher performance and integration for solutions that rely on these connected devices. In February, we announced that the Xeon 6 processor with P cores is hardware ready for TDX Connect. That means that the platform will support TDX Connect when the software and device ecosystem are ready. The ultimate solution will require a host platform with Intel TDX and TDX Connect, an enabled PCIe device like a GPU, and an enabled host OS that makes the whole thing work together. We're working closely across the industry with leading accelerator providers to make sure that the protocols under TDX Connect work amongst us so that those devices can connect easily once we're ready with the software and make your connection smooth. Let's leave that AI store and turn a corner and go down the attestation aisle. Intel Tiber Trust Authority is for customers that want independent trust assessments under a unified service, whether they deploy in the cloud, on-prem, or at the edge. Intel Tiber Trust Authority has evolved and grown since its debut in late 2023. Today, customers can choose Intel Tiber Trust Authority for their attestation needs in Azure and Google Cloud. Intel Tiber Trust Authority has also collaborated with NVIDIA and provides attestation for the NVIDIA H100. And Intel Tiber Trust Authority is even reaching out to other CPU vendors and attesting to their trusted execution environments, like AMD's SEV. Looking forward in 2025, you can expect to see Intel Tiber Trust Authority available in more and more clouds. For customers who prefer to operate their own attestation service, Intel Tiber Trust Authority is even delivering a packaged version so that you can build your own attestation service and run it independently. Intel Tiber Trust Authority also plans to add attestation beyond TEEs to their solution. It would include virtual and physical TPMs. Let's take a look at Intel Tiber Trust Authority and see how it can unify attestation and management across a diverse confidential computing estate. To do so, I'm going to turn it over to my colleague, Dave Singh, to demonstrate.
Thanks, Mike. Remote attestation is fundamental to confidential computing. And as confidential computing usage grows, IT shops will likely wind up with deployments across multiple locations. Think different CSPs, on-prem data centers, and even edge locations. Now, if each location uses its own attestation service, that'll create a lot of complexity and make management and auditing difficult and time-consuming for IT. Now, Intel Tiber Trust Authority can be your single source for attestation management and auditing, even if your confidential computing deployment stretches over many locations. Here's an Intel Trust Authority dashboard for a fictional company, Holistic Healthcare. Now, Holistic Healthcare, being a distributed installation, has confidential computing in Azure, Google Cloud. They even have an on-prem implementation of confidential AI using both TDX and the NVIDIA H100 GPU. Now, we could use separate attestation services from each installation, but Intel Trust Authority offers a unified view of the entire environment. And this can be a real time saver for security management and compliance auditing. Now let's take a little bit of a drill down. If we look at the on-prem device with the TDX and the H100. Down here, we can see a log of the latest attestations. If we take a look at a specific attestation, now you can see here, all the way down at the bottom is the token information. If we blow that up, we can see the full register of the token information. And in here, you can see that this single attestation is covering both the NVIDIA GPU as well as the TDX-enabled CPU. Now, there's no need to manage multiple services individually. It's all done with a single API. Going back to our latest attestations, we can see also if an attestation failed, we can find the reason, and that can come in handy for troubleshooting. So as you can see, Intel Tiber Trust Authority brings everything together and makes it easy to manage all your confidential computing assets. Now back to you, Mike.
Hey, thanks, Dave. That was a great demo. So folks, so far I've talked mostly about tools coming from Intel out to the industry. But many tools that will extend confidential computing's reach will develop as a collaboration amongst us as a community. Here are a few examples I'd like to show today, and I'd like to also make a call to bring your voices, bring your talents to these efforts. Join us. Let's advance the industry together. First, OPIA, whose mission is to accelerate open source, open solutions for generative AI, with an emphasis on RAG. Confidential computing is critical in the RAG space as businesses are bringing their proprietary data out to large language models, and you need some help protecting that data and protecting the entire AI pipeline. Check out the use cases for OPIA at the link provided. Containers have become the preferred unit of deployment for cloud-native applications. And Confidential Containers, or COCO project, is an effort to deliver flexible, agile container technologies that fully embrace hardware-based confidentiality and attestation. We invite you to get involved with us in COCO. Go check out the code at the link, even try out a proof of concept. Let's talk about OpenHCL. Millions of VMs run on Windows Server today, especially in the enterprise. OpenHCL is a project that enables those VMs to run in confidential computing, a key step for expanding our business into the enterprise segment. Come, join us in OpenHCL and contribute at the link shown. And join us across all of these initiatives. Let's work together and make the industry stronger. Let's advance together. Well, sadly, folks, our shopping experience is almost to an end. We've got a whole basket of tools and can head for the checkout. But before we do, let's just do a quick recap. I showed you how Intel will bring developers the foundational technologies for application isolation and VM isolation, and deliver new features like cryptographic ECC, and package those all in a compelling Xeon processor roadmap. Demonstrated how Intel Tiber Trust Authority can be your attestation solution for an entire confidential computing estate. Whether you're an enterprise provider, a cloud provider, or a software provider, we'd love to talk to you about our solution network around Intel Tiber Trust Authority. Finally, we talked about confidential computing being a community of innovators. We invite you to join us in the open source projects that we shared and help make the industry stronger together. Well, folks, that's our time together. Our shopping experience is over. Thanks for coming shopping with me at the hardware store. I hope I added some tools to your toolkit today. Hope we provided a more robust toolkit for you so you can solve more problems for more customers. That's my presentation. Thanks for joining me. I'm ready for questions.